In dimensional analysis, the Strouhal number is a dimensionless number describing oscillating flow mechanisms. The parameter is named after Vincenc Strouhal, a Czech physicist who experimented in 1878 with wires experiencing vortex shedding and singing in the wind. The Strouhal number is an integral part of the fundamentals of fluid mechanics. The Strouhal number is often given as, where f is the frequency of vortex shedding, L is the characteristic length and u is the flow velocity. In certain cases like heaving flight, this characteristic length is the amplitude of oscillation. This selection of characteristic length can be used to present a distinction between Strouhal number and reduced frequency, where k is the reduced frequency and a is amplitude of the heaving oscillation. For large Strouhal numbers, viscosity dominates fluid flow, resulting in a collective oscillating movement of the fluid plug. For low Strouhal numbers, the high-speed, quasi-steady-state portion of the movement dominates the oscillation. Oscillation at intermediate Strouhal numbers is characterized by the build-up and rapidly subsequent shedding of vortices. For spheres in uniform flow in the Reynolds number range of 800 less than Re less than 200,000, there coexist two values of the Strouhal number. The lower frequency is attributed to the large-scale instability of the wake and is independent of the Reynolds number Re and is approximately equal to 0.2. The higher frequency Strouhal number is caused by small-scale instabilities from the separation of the shear layer. Applications in metrology, specifically axial flow turbine meters. The Strouhal number is used in combination with the Roshko number to give a correlation between flow rate and frequency. The advantage of this method over the FREQ, viscosity versus K-factor method is that it takes into account temperature effects on the meter. F equals meter frequency, U equals flow rate, C equals linear coefficient of expansion for the meter housing material. This relationship leaves Strouhal dimensionless, although a dimensionless approximation is often used for C3, resulting in units of pulses, volume. This range is used in the swimming of dolphins, sharks, and bony fish, and in the cruising flight of birds, bats and insects. However, in other forms of flight other values are found. Intuitively, the ratio measures the steepness of the strokes. Viewed from the side, F is the stroke frequency, L is the amplitude. So the numerator FL is half the vertical speed of the wingtip, while the denominator V is the horizontal speed. Thus the graph of the wingtip forms an approximate sinusoid with aspect twice the Strouhal constant.